Hi children, this is your Suvarna teacher. Children, in previous videos we discussed about law of conservation of mass, law of constant proportion. By early 19th century, the scientists knew some laws governing chemical reactions. Why are these two laws valid? Why cannot the elements combine in any arbitrary proportion? That is, why mass remains the same during a chemical reaction? Why the compounds are formed by a definite proportion? Why can't in another proportion? Many scientists tried to give appropriate explanations. The English school teacher John Dalton proposed the basic theory about the nature of the matter. Dalton reasoned his proposals as mentioned below. If mass was to be conserved, then all elements must be made up of extremely small particles called atoms. If law of constant proportion is to be followed, the particles of same substance cannot be different. Based on the above laws, Dalton proposed a new system of chemical philosophy called Dalton's atomic theory. So let us see what are the postulates of Dalton's atomic theory. Number 1. Matter consists of indivisible particles called atoms. That means all the matter consists of tiny particles called atom. The word atom is derived from a Greek word atomio, that means indivisible, which is the smallest and tiniest particle in that matter, substance. Second point, atoms are neither created nor destroyed in a chemical reaction. Reorganization of atoms occurs in chemical reactions. This postulate is the result of the law of conservation of mass. That is, a chemical reaction takes place and the mass remains the same before and after the chemical reaction. The third point of Dalton's atomic theory is all the atoms of a same element have identical mass and identical chemical properties. Atoms of different elements have different masses and different chemical properties. That means the atoms of same elements are having identical, that means same physical and chemical properties. The atoms of different elements are entirely different from each other in physical and chemical properties. For example, children, atoms of oxygen, that is, oxygen is a gas, and atoms of gold, and gold is a solid. Atoms of mercury, and mercury is in liquid state. That is, the atoms present in the same elements are having same physical and chemical properties. The atoms of different elements are entirely different in all aspects. Coming to the fourth point, compounds are formed when atoms of different elements combine in simple whole number ratios. That is, chemical change is the union or separation of atoms as in whole numbers. When two atoms are formed, oxygen atoms are formed, they produce same identical molecule. For example, oxygen. In oxygen, there are two atoms which are having same oxygen atoms. The two oxygen atoms will combine and form oxygen. It is a gas. When the same oxygen atom combines with two hydrogen atoms, it produces water, and it is a liquid, and the water is entirely different from oxygen. That is, chemical change is the union or it may be separation of atoms in whole numbers. When we decompose water, it produces two atoms of hydrogens and one atom of oxygen. The final and the fifth point of John Dalton's atomic theory is when atoms of different elements combine in different whole numbers of ratios, they can form different compounds. Example, this postulates, children, do you remember? This postulate explains the law of constant proportions. When one atom of carbon, example, when one atom of carbon and one atom of oxygen combine and form carbon monoxide, CO. The ratio of carbon and oxygen in CO is, that is carbon monoxide, is 1:1. In case of carbon dioxide, when carbon and oxygen combines in a ratio of 1:2, that is 1 carbon and 2 oxygen atoms, and it is called carbon dioxide. The 1:1 formula compound carbon monoxide, 1:2 formula compound carbon dioxide, both are different compounds. They possess different physical and chemical properties. So this postulates explains about the law of constant proportions. Now children, you are thinking that Dalton is the first person who proposed the concept of atoms, isn't it? No, you are wrong. About 2600 years ago, an Indian sage means rishi, called Kanada, also postulates the atoms in his Vaisheshika Sutra. The actual name of Kanada was Kashyapa. He was renamed after his Kanasiddhanta. That means he proposed the Kanasiddhanta even before 2600 years ago. Kana means in Sanskrit a teeny particle. This Kana, we can compare the atom of John Dalton's theory. He proposed that all forms of matter are composed of very small particles known as anu. Anu, that's why we are also called it as molecule, and each anu, it can be splitted or it can be separated, made up of still smaller particles called paramanu. This paramanu, it will be resemble with the word atom with John Dalton atomic theory. Now, very interesting and very inspirational, isn't it? There are so many ancient Indian scientists who discovered and proposed so many concepts and theories before the so-called European and American scientists. There are so many scientific concepts which are there in our Vedas. So children, that's all for this session. Thank you very much.